I'm Jake O'Neill, creator of Animagraphs, and this is how a manual transmission and clutch works. Manual transmissions are rare in new consumer cars, but millions of units still exist in older cars, commercial, and racing applications. For this video, we've chosen a front-wheel drive arrangement. Our transmission model is a constant mesh type design where gear sets are always in contact with each other. Let's start with the clutch. The clutch assembly is securely attached to the flywheel, which is bolted to the engine. It's always spinning if the car is running. The components inside this assembly allow power flow to be disconnected from the transmission input shaft. Note that the transmission input shaft does not itself connect to the engine crankshaft or flywheel. Connection to engine power is accomplished with a sliding friction disc, sometimes called a clutch plate, sandwiched between the flywheel surface and a movable pressure disc. The clutch plate assembly is splined to the transmission input shaft, but can slide back and forth. The pressure disc gradually squeezes everything together as the driver releases the clutch pedal for a smooth connection to engine power. To further ensure smooth power delivery, the clutch plate has a built-in damping system. The friction plate floats on the transmission input shaft. Power flows from the disc through damping springs which push against a rotating top plate whose center is splined to the transmission input shaft. The springs continuously absorb vibrations or other potentially harmful anomalies in the flow of power. Now let's look at how the pressure plate moves. The pressure plate is connected to a special diaphragm spring. This strong spring is what naturally presses the pressure plate to the flywheel. The outer cover has hooks that hold the diaphragm spring securely in place and act as a fulcrum. There are also supporting leaf springs attached to the pressure plate and cover. The clutch fork sits at the center of the diaphragm spring. As the clutch fork pivots, it presses against a release or throw-out bearing, depressing the diaphragm spring's inner prongs, which in turn lifts its outer edge and the connected pressure plate. Let's see that movement a few more times. The clutch fork acts as a lever with a fulcrum point on the transmission case interior surface. It's driven by a hydraulic actuator whose lines lead back to the clutch pedal with its own hydraulic actuator and fluid reservoir. The gears. Each speed has a gear set so that input speed can be different from output speed. The speed gears in this constant mesh transmission are always linked. They have diagonal or helical cut teeth for quieter operation. Notice the reverse gear set with its straight teeth. This transmission will make a familiar gear whining sound when in reverse. Engine power flows through the main shaft, to the counter shaft, to the differential assembly, and out through front axles. Synchronizing gears. To make gear shifting possible, one gear in each set floats freely on its shaft, riding on a roller bearing. The other gear in each set is either connected with splines or directly machined into its respective shaft. For power output, the floating gear in each set must become securely connected to the shaft through the synchronization process. Between each gear set, there's a synchronizer hub that's splined